All right, hello again, Alpha G people. So in today's video, we're going to talk about how to solve a quadratic inequality. The good news on this is it's going to start the exact same way. You already know how to solve quadratic equations. But then there's a process at the end, because it's not just one or two solutions that you've been normal to finding. There's an infinite solution. So there's going to be a solution set to these that we'll have to do. The steps are right here. I'm not going to read these out to you. If you want to pause the video or take a screenshot, something like that, you can certainly do that. But I'm going to kind of jump in, and we're going to do these steps as we do the problem. And I've got 4 examples here. So the first thing I'm going to do, so we see it's got a 0, so we're good there. I'm just going to pretend for a minute that it's an equation. So I'm going to write it 3x squared minus 3x minus 10 equals 0. And by now we know how to solve this. We can factor it and get the solutions that way. So we know that that can be factored as with -5 and +2. And we know from there our solutions are 5 and -2. And again, if that's what the problem was, we'd be done and go on to the next one. But we're not done. So what we have to do is we have to make something called a sign chart. Now it's a fancy name for a number line, but you'll see why we call it a sign chart in a couple minutes. You will see these kind of pop up again in pre-calculus, and definitely if you go on to calculus, you'll see sign charts pretty often in there. So it's a good skill to kind of start getting your head around. So what we're going to do, we're going to take these two numbers here, our two solutions, and just put them on the number line, obviously, in the order that they go. So what we've done, we've divided the number line into intervals. So this interval is from -infinity to -2. This interval is from -2 to 5. And then the last one is from 5 to infinity. And I'll go and put those in the box too. Doesn't really matter where you write them, but I like writing them on the sign chart itself. But just so my boxes aren't empty, I'll put it there too. So here's what we have to do with this. So in each interval, we can pick a number, literally any number in that interval. So like in my first interval here, any number you pick between -infinity and -2, we can do. So I'm just going to pick the easy one at -3 and plug it in. Here's a pro tip for you though. Don't plug it into the original standard form. Plug it into factored form because it's going to be easier. All we need to do, we don't even care about the number itself. All we care about is if it's positive or negative. That's all we care about. So I'm going to plug in -3 into factored form. And when we do that, we have -8 times -1. And again, all I care about, negative and a negative, is a positive. So I'm going to put a plus in that whole interval. Now, I don't want to go down the whole rabbit hole here, but there's a theorem called the IVT, the intermediate value theorem, that says essentially that if you have it broken up into intervals where your zeros are, then any number you pick in that interval, the behavior of the function is going to be the exact same thing. Okay, so this tells us I picked -3. If you decided to pick -5 and someone else decides to pick -10 or whatever, they're all any of those numbers in that interval will all end up being positive in that interval because of that theorem called the IVT. So we just repeat the process in each interval. So pick a number between -2 and 5. I'm going to pick 0 because that's the easy one. And again, just plug it in to a factored form. And that comes out to be a negative number, so I'm going to stick a negative right there. And then the same thing for the last interval. And again, anything bigger than 5, so I'm going to pick 7. And we have +5 and +9. Or +2, I should say, sorry. But again, doesn't matter. They're both going to be positive anyway, so I get a positive. At this point, now you can see why we call it a sign chart, because we put signs on a chart. But this allows us to answer the question. So now we go back to our original inequality. So it was x squared minus 3x minus 10 is less than 0. And now we just say, well, if I want it to be less than 0, clearly I want in the interval where the function values were negative, less than 0. And in this case, it's that middle interval. So my answer, my solution set, is -2 to 5. Okay. Now, the one thing I do want to point out just real quick before we go on to the next question is, if this had been a greater than, obviously we would have had those two. We're going to see another example with a greater than, so we can see how to write that solution set. But the other difference I want to say is, what if the question had been this? What if it had been less than or equal to 0? How would this solution be different? It's all the same work. We don't have to do anything different here. But now, if you remember interval notation, our answer, because it was just less than, means anything between -2 and 5 will answer the inequality. But it can't include that. Now we can include it. So the only difference would be writing it with a bracket instead of a 5. If you remember the two things with interval notation, we either use brackets or parentheses. And that's the whole process. So we still factor it and solve it the same way we always do. Set up your intervals, test numbers in each interval, and then you can answer the question just being mindful of your parentheses and your brackets. So let's look at another example here. I'm going to let you guys do one on your own in just a minute. So we have this, and again, we're just going to pretend it's equal to 0 for a second. And we factor that. There's a bunch of different ways to factor it. I'm just going to write down what the factors are. So we know it's going to be 2x and x. And then from here, it would be -4 and plus 5. And then our solutions here, again, 2x plus 5 equals 0. So we know x would be equal to -5 over 2. And x minus 4 equals 0. Solve that. We got x equals 4. And again, stick them on the number line. Set up your intervals. And then we just start testing numbers. And again, pick any number you want in that space. So anything less than, between -infinity and -5 over 2, which is -2.5. So I'm going to pick -3 and plug it into factored form. And let's see, that's -6 plus 5, that's -1, and -7. So again, all I care about is the sign, so that's going to be a positive. Pick a number between -5 over 2 and 4. I'm going to pick 0 again. And we have 5 times -4, which is a negative. And you can probably guess what's going to happen in the last interval. Anything greater than 4, I'll pick 5. And we have, 15 times 1, and that's a positive. So now we go back to our original inequality, which was greater than or equal to. So we got 2x squared minus 3x minus 20 greater than or equal to 0. And you just think, okay, greater than or equal to, what do I want? I want the positives. So I need both of those two intervals. And it is equal to, so I'm going to use brackets on the boundaries. So negative infinity to negative 5/2 with a bracket 4 to infinity. And remember, if we have two different pieces of our solution set, we put the union symbol in between there, and we're done. So here's a third example. I'm going to ask you to pause the video and work through this on your own. The one thing to notice is make sure we do have to have it, just like before, we have to have it equal to 0, or have everything on one side of the equal side. So make sure and do that first. Okay, so if we get everything on one side, obviously we have to subtract 8 from both sides. We have to add 4x to both sides. So we have x squared minus 5x plus 4 is less than 0. And again, I'm going to pretend that's an equal sign. We can factor that pretty easily. That's just negative 4 and negative 1. And so my solutions are x equals 4 and x equals 1. And stick that on our sign chart. Make our intervals. And start picking numbers. And again, if you pick different numbers that I'm going to pick, totally fine, as long as they're inside that interval. First interval, I'm going to pick my 0, my favorite number to pick if I can. So it's a negative times a negative, which is a positive. That probably doesn't surprise you at this point. Anything between 1 and 4, I'll pick 3. That's a negative, also probably not surprising. Anything bigger than 4, I'm going to pick 7. And that's a positive. And now we can answer the question, and the original question was a less than. And so if I want the less than, I'm looking for the negative pieces. So it's that middle piece, if you will. So my solution set is 1, 4. Couple comments at this point before we do the last example. You might have noticed all three examples had that same plus minus plus pattern. Don't get beholden to that. Don't be, I don't want to sound mean when I say this, don't be lazy. Usually, especially with quadratics, that same pattern will happen, but it does not always have to happen that way. And especially as you get into higher order polynomials, third degree, fourth degree, stuff like that, different things may be happening. So don't always get the first one and say, oh, it's going to alternate. That is not always the case. Also keep in mind that even though your intervals may be small, like this is just between 1 and 4, there's still an infinite number of solutions to these things. So just kind of keep those two little tidbits in mind. So I've got one last example I'm going to do, and we'll wrap this up, because I want to do one that doesn't have that same plus minus plus pattern. And you can probably see right off the bat, this is a little bit different because I've got a negative x squared in front. So I'm still going to treat it like an equation. But what I'm going to do, I'm going to factor that negative 1 out. So just like a GCF. So if I take the negative 1 out, I've got x squared minus x minus 6. And again, treat it like an equation. Now I can factor the inside to be x minus 3 and x plus 2. Now that negative 1 doesn't affect the solution, so my solutions are still x equals 3 and x equals negative 2. So everything else is the same. And we still pick our numbers. The only catch on this particular example, when we're choosing our numbers, like anything between negative infinity and negative 2, I'll pick negative 5. Don't forget when you plug it in, again, still use factored form, but don't forget about that leading negative 1 that we factored out, that GCF. So it would be a negative 1 times negative 5 minus 3 and negative 5 plus 2. So negative 1 times negative 8 times negative 3. 3 negatives would be a negative. Okay? Any number between negative 2 and 3, I would pick 0. Negative and a positive, that is a positive. And you can probably take a wild guess at what's going to happen with the last one. I'm going to pick 4. And that's going to be a negative. So you see basically what happened on that with that leading coefficient as a negative, it basically just flipped the order. Instead of positive, negative, it's negative, positive, negative. But again, keep in mind, I know we didn't see an example like this, and they generally don't pop up a whole lot in Algebra 2, but later on, you can see things that do not alternate. So again, check your intervals to make sure what's happening. Solution set, same deal. The initial problem was less than or equal to. So I want the less than intervals, so those are the two intervals kind of on the ends, if you will. And this equal to, so I'm going to use brackets. And that is how you solve quadratic inequalities. As always, if you have questions, you can send me a message, drop an email, talk to your teacher if you don't have me. And until next time, stay safe.